Hello and welcome to this Aruba CX 10.11 update. I'm Kamal Takodra and I'm a technical marketing engineer in the Aruba Business Switching unit. Today I'm going to cover Parity features and enhancements, part 1 of 2. Please watch out for part 2 of 2, covered by my colleague Steve Bartlett. So what we're going to cover in this session is something called ERPS support, ARP protection, first hop security, SFlow Egress, port LED behavior, SNMP Traps, some scale improvements, and some mirroring port changes. So first of all, we're going to be covering Ethernet ring protection switching. So Ethernet ring protection switching now includes support on the 4100i, and we can see from the table below the platforms that now support ERPS, including 4100i, are the 6300, 6400, 8320, 8325, 8360, 8400, 9300 and 10,000. Now ERPS is a layer 2 protocol that effectively is in a ring topology and will provide convergence in a sub-second. So what are the use cases for ERPS? Effectively, we have major customer sort of topologies that we think it's appropriate, and we see it in there. It's typically metros, university campuses, airports, power substations, railway stations, which can require this. As shown in this topology here, we can see a ERPS ring in a railway environment, and the 4100i is really positioned in those type of environments because it's ruggedized and has high temperature and shock properties. So it was very natural to get ERPS included in this platform too. So just a bit of a refresher on ERPS. So here we show ERPS configuration with 4 switches in what we call its idle state, and we have something called a ring protection link owner and a ring protection port link neighbor. And in an idle state, typically this link between the owner and the link neighbor is blocked to traffic, and the topology, logical topology, is shown below. It's like a bit of a horseshoe actually. Now under a failure scenario, so this link here fails, what will happen? We will get a reconvergence, and these links that now are blocked because of a failure either of a node or of a link. In fact, this becomes unblocked for user traffic, and the logical topology now becomes as shown in the protection environment. I've also shown some very basic configuration for each of these switches in this 4 ring topology. We define ERPS ring. We define the ports that ERPS is going to traverse over in terms of the protection of the links. We define an instance, enable it, then we define the VLANs that we're going to push over the protected links effectively. So these are protected VLANs, and we have to define an RPL owner, and this will be switch 1 in this case. And then we also have a RPL port, and we have something called a control VLAN, which messaging is carried over on the ERPS fabric effectively. And then switch 2, which is the RPL neighbor, is defined slightly differently, where we actually define it having being an RPL neighbor role. And the remainder of the switches are very basic configuration, where they have just defined their ports and the instance, and the same for switch 4. So let's move on to the next feature. So our next feature is ARP protection. And so we now have ARP protection, or ARP inspection as it's known in the configuration, included on the 4100i. So the 4100i now joins the existing platforms that have it already, which include the 6000, 6100, 6200, 6300, 6400 and the 8400. As we know, ARP is used for resolving IP to MAC addresses and has no inbuilt security, so can be vulnerable to attacks. So too many ARP packets can overwhelm the switch control plane. Also, if we have unresolved ARP packets, or too many of them, again, this can overwhelm and impact the switch control plane. And we also could have bad actors wrongly advertising ARPs too. So we need to protect against all these type of things. Hence ARP inspection. Just really covering dynamic ARP inspection on Aruba CX. So you can enable or disable dynamic ARP inspection at a VLAN level. You define the ports of that VLAN as either being trusted or untrusted. We only check for ARP inspection on untrusted ports. Rooted ports or rooted only ports will be treated as trusted, and we don't carry out checks on that. And we use the existing binding table to carry out checks on the ARP. So let's have a quick look at the configuration. So under the VLAN context, you just put in the keyword ARP inspection. That turns it all on. Now by default, ports are untrusted. This configuration shown here isn't actually shown in the config. So if you wanted to make a change, you could put this configuration in, but won't exactly be seen because this is the default configuration. Now if you wanted to not have any inspection on a specific interface, you would put the ARP inspection trust, and it wouldn't be used or checked on that specific interface. So let's go on to the next feature. So our next feature is first hop security and DHCP snooping. So we now have for AOS-CX 10.11 DHCP snooping, both IPv4 and v6 for the 8325 and the 10,000. Just as a reminder, DHCP snooping is there to protect us from unwanted and rogue DHCP services posing. Typically, we're looking on those LAN ports. So the 8325 and the 10,000 are new to the game for 10.11. They have a scale of 2048 bindings per port or system. This is shared between IPv4 and v6. Obviously existing platforms are 4100i, 6000, 6100, 6200, 6300, 6400 and the 8360 and 8400. One thing I should mention on the 10,000 series is that DHCP Snooping and the PSM distributed services are effectively mutually exclusive. If both features are enabled, you may get some very unexpected behavior, and we don't recommend that you switch them both on effectively. Right, I'm just going to cover a really basic config as a refresher. We have this typical setup for v4. We have DHCP services that we trust. We have an access switch which has got VLAN 120. So you basically enable DHCP v4 snooping globally. I've enabled snooping for the authorized servers and allowed those, so we're expecting from these two servers here. Then under the VLANs, I've enabled DHCP snooping, and then we have user VLANs, and because they do have no configuration, for instance 111 to 1115 here are user VLANs. It's on by default, and then on one of the uplinks I've shown that we've trusted DHCP, so we're allowing that coming through. So let's move on now to the next feature. So the next feature is SFlow. So SFlow is used for detection and analyzing and get some insights on packet flows. For 10.10 we had the following support as shown here. Now for 10.11 we have now added the 8400 to have egress SFlow, so it joins the rest of the switches to have both ingress and egress SFlow from the 6200 all the way up to the 10,000. On to the next feature. So we have a port LED behavior. So this is specifically only for the 6200. So the change here is that when we have traffic at approximately 40% or below line rate, we'll see the port LEDs will blink with a shorter on time and remains at lower brightness for a longer period. That's the main change. Other things that you'll see, which similar to other switches, are that around 70% line rate we'll see vigorous blinking or a flicker. It's really no change. That's similar to all switches, and again not a change, but worth mentioning that when you have a maximum line rate, port LEDs remain on and they're not blinking at all. So let's go to the next feature. So it's SNMP Traps. So we have a new SNMP trap. So it's to do with firmware upgrades. So when there is a firmware upgrade, we will get a trap. This is for all current CX platforms, and this is the MIB event. And shown here in this output, I've carried out a TFTP to a switch, and I've done the show events, and we can see on the switch the firmware version, what it was before and after the update. And then this is on a SNMP trap receiver. We see the same message here too. While I'm covering SNMP, I'd like to cover a short demo on how to find info on CX MIB with some basic orientation. So those who want to find out a bit more information around SNMP MIB supported on Aruba CX switches, I suggest you go to arubanetworks.com and then log in and go to the Aruba support portal. Once you are logged into the support portal, which I already am, you can then go to software and documents, and then you can search for the MIB files and see what's supported in the CX switches. So you could, I'll just filter here and I'll filter on CX switches, apply that. I want the latest, so I'm gonna go for version 10.10, which is currently available based on this public web page. Apply that, so that's taking me to 10.10, and then I'm going to filter on SNMP and MIB. So that has now taken me and filtered me down to this MIB file, so I could download this file, and it's simply a download of a tar file, and it will download it to my PC. I've already downloaded it, and I've actually then expanded that tar file into this folder. So if we go into that folder very quickly and have a look, this is the expanded folder, and very important, there's a readme file, so you can open up that readme file, and that readme file gives you the latest changes on the MIB, and you can have a look at what's supported. Now if you have an interest in a specific MIB, you can then go into that expanded files and simply use the text editor to read that. So I'll just take one at random, so I can look at the power over an Ethernet MIB, and then I can I'm going to look at it with something called Notepad++, and it becomes a human readable format effectively, and then you can have a read and drill down into what's supported and what's covered in those specific MIBs for the CX switches. So I hope that was useful. Now we'll look at how to do an SNMP walk on a live switch to help you with looking into the specific MIBs for a specific switch. So if you wanted to find out about the MIB supported or on an actual Aruba CX switch, you can run an SNMP walk on a switch itself. So here I've got an Aruba 6000. It's got very basic configuration. We've got an SNMP server in command in default VRF, and I've just got the community public set on this switch, and I've got access to this on the IP address 10.6.10.9. So I've got a regular Windows server, and I've got SNMP walk installed on here. So if I run SNMP walk, what will skip past you all the different options and switches that you can put in to see what's information you're interested in of that specific SNMP walk. So I'm going to run an SNMP walk on this 6000 switch. I've got a few switches here, capital O B E N and then a capital U, to allow me to get some OID information from the switch. I'm running version 2 SNMP, and then the community is the -c is public, and that's the IP address of the switching question, as we can see, 10.6 10.9, and then I just simply hit return, and I should get a response. There you are, from the switch. And obviously it's a lot of information to take in, but you can see you can run an SNMP walk. So let's stop that there. Now if I wanted to look at the actual switch at leisure, I can just so that's a lot of information to digest as it scrolls down past you. So you can actually instead of having it scroll past the screen, you can actually push that SNMP walk into a text file, so you can look at that later. So we can just hit return and run that command, and that will push it to a text file, and once that's done we can have a quick browse of that. So now that's completed running, let's have a quick look at the text file which I've put into the downloads directory, and there it is. So I can just open that up with Notepad. Hopefully that's open. Yeah, okay, so that opens up straight away. You can see that we've got the details about the switch. It's a 6048 port, and then as we go further down we can see we have all the different OIDs and all the details about the specific switch, and it goes on for quite a while, so you can look at it and at your leisure to find out. And you can run this on any of the Aruba CX switches using SNMP walk. Obviously you can change the different parameters to see what you're interested in. So I hope that was useful and a bit of insight into SNMP on Aruba CX switches and how to interrogate them. Let's move on to the next feature. So we have some scale improvements. So the scale improvement is to the switch virtual interface and MAC address capacity of the 6200. So prior to 10.11, the MAC address capacity on the 6200 was 16K, and we've now upped that to 32K as of 10.11. And the number of supported SVIs was 128 before at 10.10, and we improved that to double to 256 SVIs for 10.11. And I've just done a show capacities here and shown the relevant parts. You can see on this 6200 that we've now support exactly 32768 MAC addresses, and then the number of SVI supported is 256. Let's move on to the next feature, which is mirroring ports. So we've increased the scale of mirroring ports for the 4100, 6100 and 6000. Prior to 10.11 we only supported 4 source mirroring ports, and now we've upped it to 52 source ports. And you can see from this example I'm running 10.11 here, and on the 6100 I've been able to configure more than 4 source ports. In fact, I've configured 6 source ports here to a destination of 1116. Thank you for watching this update on Aruba CX 10.11 update on parity features and enhancements. Please be sure to see part 2 of 2 covered by my colleague in technical marketing, Steve Bartlett. Thank you.